So in this question, we're told that x is modeled by a normal distribution with a mean of 31 and a standard deviation of 3.5. A sample of size 20 is taken and the sample mean is 32.5. We're asked to test at a 1% level of significance whether or not there's evidence that the mean has increased. So in these three sentences, we've been given all the information that we need to conduct this hypothesis test. I'm just going to go back through and pick out some of the important information and explain how it's used. So we are told that the normal distribution has a mean of 31. 31 is going to be used in multiple places in this working out. So because the normal distribution mean of 31, so the population mean, this is in the hypotheses. The null hypothesis is always that mu equals 31. And our alternate hypothesis we're going to take from this phrase, where we're testing for evidence that the mean has increased. So the alternate hypothesis, mu is greater than 31. The hypotheses here must both be about mu. That's what we're testing. We're testing the population mean. Since we have this, we have enough to state the x distribution. X follows a normal distribution where mu equals 31 and the standard deviation is 3.5. And this is the way we would usually write that. So 31 and 3.5 squared. We're always showing the variance, and we're showing that variance in the form of standard deviation squared. Our significance level is 1%. We'll write that as a decimal. And our n value, that's the sample size, earlier in the question we were told that that's 20. I'm summarizing these so I can actually write the x bar distribution. That's the distribution of the sample means. This is the distribution that we'll be working with for this question. Now, as I said earlier, the 31, the population mean, appears in lots of places in this question. 4 places in total. The null hypothesis, the alternate hypothesis, the x distribution, and the x bar distribution. Here's another 31. The standard deviation or the standard error is going to be 3.5 over root n. It's going to be sigma over root n. 3.5 over root 20. And that I'm going to show as being squared so that it's actually the variance. And once again, we're going to show that as being squared. The reason we do this is because the value to go into your calculator is the bracketed version. We are putting in the bracketed expression into your calculator. Okay, that should be enough to get going on the diagram. The 31 appears in a 5th place. The population mean appears in a 5th place. It is the mean of this distribution, the middle of this distribution. So, we've spoken about the population mean a lot. There is a second mean in these questions, and this is the sample mean. The sample mean being 32.5. And this only really has one use in the whole of the question. We should have been able to do all of this without even knowing the sample mean. But the sample mean, which we're going to use x bar to represent, so these are 2 different means. That's why they have 2 different symbols. Population mean is mu, sample mean x bar. X bar needs to go onto this diagram, and we're checking whether our particular sample mean, whether or not it's going to give a significant result. Once we put it on the diagram, we know we can shade in the extreme end. And the actual probability, the actual area that we're trying to calculate is the probability that x bar is greater than that 32.5. Okay, well that can go into our NCD format as usual. 32.5 for the minimum. We'll go with 1,000 for the maximum. And here's our standard deviation, 3.5 over root 20. And then 31 is the mean. And that gives us 0.0276. Okay, now we can make a comparison. We're comparing this is our p-value. We're comparing our p-value with the significance level. 0.0276 is greater than our significance level, so we do not have a significant result. This is not significant. There is not enough evidence to reject H0. And if there's not enough evidence to reject H0, and that would be the first part of our 2-part conclusion. That's our mathematical conclusion. And if your question had some context, had a story, had a scenario to it, that would form the second part of your conclusion.